Given an integer, we have to return true if the integer is a palindrome and return false if it's not. Now, a palindrome is a sequence that reads the same backwards or forwards. For example, these numbers are palindromes because reading them backwards still results in the same number. However, these numbers would not be palindromes because they result in something different. Now, there's actually a very simple way to do this, which is to first convert the integer into a string, reverse it, and then see if the reverse string is the same as the original string. And this right here is just Python's way of reversing a string. Now, this solution works, but the question challenges us to solve this without converting the number to a string. So here's how we're going to do it. The idea here is that we don't actually need to reverse the entire number. We only need to reverse half the number. For example, if this is the number, we can just reverse the first 3 digits and then compare these two to each other. If they're the same, then the number was a palindrome. But how will we know when we've reached the halfway point? Well, since we're transferring digits from the original number to the reversed half, the original will be greater than the reversed half until we reach the halfway point. When the original half is less than or equal to the reversed half, we know that we're done. We can also handle numbers that have an odd number of digits, but we'll just have to recognize that the two numbers will be off by 1 digit, which will be attached to the reversed half. So let's take a look at how we can do this in Python. Let's assume 1221 is the number x that we are given. First, we need to take care of some edge cases. If a number is negative, then it can never be a palindrome, since the minus sign would always appear on the opposite end, so we can just return false immediately. The other case is that no number ending in a 0 can be a palindrome, because it would also have to have a leading 0. For example, for the number 10 to be a palindrome, it would have to be written as 010, which is not a valid way of writing numbers. So the way we test if x ends with a 0 is by calculating x mod 10. Remember, the modulo operator returns the remainder after performing division. So if the remainder after dividing x by 10 equals 0, then the last digit is a 0, and we can return false. Now the only exception to this rule is the number 0 itself, so we also make sure that the number isn't 0. Next, we'll create a variable called half that will contain the reversed half of the number. Now we'll enter a loop as long as x is greater than half, which is how we'll know that we've reached the halfway point. So now we'll update the half variable, and I'll do this in 2 steps to make it clear what's happening. So first, we'll multiply half by 10, which doesn't do anything right now since half equals 0. Then, we'll take x mod 10 and add the result to half. Well, 1221 mod 10 equals 1, so now half equals 1. The next step is to update the x variable using floor division. Remember, floor division will round the result down to the nearest whole number. So 1221 divided by 10, then rounded down, is 122. Notice that what we effectively did was transfer the 1 on this side over to the other side. Now 122 is larger than 1, so we'll loop again. First, we'll multiply half by 10, so 1 times 10 is 10. This is so we can make room for the digit that we're about to transfer. Next, we'll do 122 mod 10, which is 2, and add that on. So now half is 12. Next, we'll do floor division with 10 again to update x, and 122 divided by 10, rounded down, is 12. At this point, 12 is not greater than 12, so we'll exit. For the last line of code, we'll check 2 conditions, and if either of them are true, we'll return true. Remember that if the original half is equal to the reversed half, then the number is a palindrome, so that's what we check for here. In this case, 12 is equal to 12, which means we do have a palindrome. Since this part is true, the function will return true and we are done. Now you may be wondering, what about this part? Well, that's the part we have to use if x has an odd number of digits. Let's do another example to see this. Let's say 12321 is our new number. The function will start out the same way by declaring a half variable and entering the loop. The next 2 iterations are essentially the same as the previous example. First, we'll multiply half by 10 and add 1, so half equals 1, and we'll reduce a digit from x. Next, we'll multiply by 10 again and add 2, so half equals 12, and we'll update x so that it's now 123. At this point, x is still greater than half, so we'll loop one more time. We'll multiply half by 10, and now x mod 10 equals 3, so half equals 123. X is then updated to be 12. Now x is less than half, so we exit and evaluate the return statement. 123 is not equal to 12, so this part is false, so let's evaluate the next statement. Here, we recognize that half may have one extra digit at the end, so we'll floor divide half by 10 and then compare the two. Now 123 becomes 12, and we can see that they are equal to each other. Therefore, the number was a palindrome, and the function returns true.